Hi everyone, my name is Aditya Rawat and my team is here to solve the retailer's biggest problem, inventory imbalance. Now, retailers often face overstock in one region and stock out in another. The result? Missed sales, wasted stock, and frustrated customers. Why does this happen? Because most inventory systems rely on static forecast and ignore real world human behaviors. To solve this problem, we have built a smart adaptive inventory management system that doesn't just predict demand, it understands it. Our system uses machine learning to forecast product demand in each region. It also takes into consideration the suppliers and their performances and give them weights according to them. Now let's understand the working of this whole system. So as you can see, this is the client side here. Now client can input product name and our LLM will generate external factors, website associated with those external factors. Our client will send a post request to the server 1, which is our ML model, and it will generate an output. But this output is just a theoretical output. It can be wronged, just like I told you before. So we have another server 2, which is external factor. Now this server scrapes all the information related to the factors which were generated by the LLM and provides each of them weights accordingly. And then the weights and the output from a server 1 is stored in a time series database. Now this is a special database which have very fast retrieval speed and storing speed of data and is used for analyzing stock market exchanges or high frequency trading. Now then the server 3, which is our LLM model, takes the first column or first row from the database and fine tunes the output data from our machine learning model in real time and stores it back to the database. Now this in return is received by the frontend from a GET request from our server 3, and it displays the data, the final data, in a graphical manner to the client, which can be a store manager. And also it sets the minimum and maximum limit of if the prediction falls behind that limit or rises up that limit, it triggers a fallback mechanism. And a post request is sent back to our server 2, which is our external factor server. Now, our server 2 detects which factor failed to predict care carefully and more accurately and recalculates its weight. Like just like in this case, our factor, which is tax was weighed incorrectly because it couldn't predict the volatile nature of the budget session, due to which the silver prices increased. It further corrected and sends it back to the database, therefore improving the model in real time and training it for the future data more precisely and more accurately. So over to Mr. Naveen on how the machine learning backend actually works, and a quick demo on how our server 2 actually works.
Let's understand the functioning of the ML model. For the testing, we have selected the silver item for category, and here is the past 10-year data which we have used for the training. So the workflow is like that. The outcome is passed to the fine-tuned LLM with an external factor for the final outcome. So let me run this. And in the meantime, I will show you the model parameters and performance. So for the price prediction model, here are its parameters and performance matrices. And for the model training, we have used the mainly time series analysis model like LSTM and with the regularization methods like RIS and LASSO. So, and similarly, here is the volume prediction analysis. Let's see also that these are the model analysis and parameters and final outcome. So let's see the output of the LLM. So this is the LLM output, and here is the result. On the basis of the external factor, as the market price, as the silver prices depend on the market situation, so we have used the external factor, and here is the final outcome, the performed by the LLM on the basis of the adjustment.